The next step is we will prove that this statement is true, and we will prove this statement by using the same technique as the previous proof, that is to find the generating function that can represent Q and M, and we found that Hx can represent Q and M because the first bracket of Hx is represent to the number of M that we use in our partition, and the second bracket can represent the number of M plus 1 that we use in our partition. So Hx can represent Q and M, and then we can simplify it into Hx equal to this product, and then we get our result. The next step, this is three statements that we have already finished the proof. The first one is the equation is involve Pn. The second one is involve Pn, M, and the third one is involve Q and M. And it is clear that the product of some expression from index run from 1 to infinity, it's always equal to the product of the same expression which index runs from 1 to m and multiply by the product run from m plus 1 to infinity, and then we multiply by x power to m both sides of our equation, and then this one can transform to this summation, and this product can transform to this product, this summation, and then this product multiplied by x power to m is equal to this one. And we use this equation to compare the coefficient of x power to n plus m both sides of our equation, and then we get if n not less than m, Pn is this, and in another case, if n is less than or equal to m, we get Pn is equal to Pn plus m, m. And the next step, we will show that we will transform Q into P by proving this statement, and we will prove this by consider the case of n equal to 10 and m equal to 2. For example, Q10 is how to write 10 into how to write 10 into parts which the minimal part is not less than 2. So the left hand side of the slide is all of the possible ways, and when we subtract one from every number, the right hand side is very interesting because 9 can represent P91 because it is how to partition 9 into one part, and the next 4 line is how to partition 8 into 2 parts, how to partition 7 into 3 parts, how to partition 6 into 4 parts, and how to partition 5 into 5 parts. So if we sum up all of these functions, it will equal to Q10. So we use this observation to generalize into nm variable. So we get the first one and the second one, and then in the second one we substitute n by m plus I and m by m plus 1, and we will get our result. And this is our conclusion. In case n greater than m, Pn is equal to this expression, but in another case, Pn is equal to Pn plus m, m. And we'll show in case n equal to 8 and m is equal to 2, to guarantee that our formula is true. We substitute them into our formula, and then we calculate each value of function. So we can see that we can calculate it easily because P10 we can count 9 plus 1, 8 plus 2, 7 plus 3, 6 plus 4. So, and we find all of the function, and then we got the answer 22, which is equal to the all possible way if we directly count it. So this is guarantee that our social is true. So thank you. This is our reference. Thank you for your attention.